when you're solving an equation, I'm going to say to solve equations. This is night one of to solve equations. The number one thing that you want to think of is doing the opposite to cancel things. So think to yourself throughout this entire course, whenever you're trying to solve for your variable, your x, y, whatever it happens to be, remember that opposites cancel. And I'll explore that more in a second. Also, a very important rule is that to maintain an equality, to keep the statement true and not break the relationship that's been set up, you are always allowed to do stuff as long as you do it to both sides of the equal sign. So property of equality, I'll say to maintain equality instead of property. You must always do the same operations to both sides. Same thing, both sides. This right here would carry you so far into algebra. I mean, this is like the golden rule of algebra. Don't mess up the relationship by changing the problem. To do that, to not change the problem, you do the same thing to both sides. Keeps the thing true, keeps the equality there. And then remember that our opposites cancel. That's a good strategy to use when you're solving. When I say opposites, let's recall some stuff. Remember. Opposites. You learned about this in chapter 1. We called them inverses, remember? We said that if I had a positive 3, what would kill my 3 to give me a 0? A negative 3? Okay, so positive 3 and negative 3 are opposites, right? And you can note that. I mean, that's because if you said positive 3 minus 3, you get a 0. They kill each other, right? What about multiplying? If I had, I don't know, 2/3. To cancel that, what would I times it by? What would be its opposite? Well, how about flipping it using the reciprocal? With the inverses, I don't think I showed you actually with the fraction, but I did show you that, like, for example, if you had 2 times 1/2, that's probably what you're more familiar seeing, actually. I should have started with that one. If you had a 2 times the 1/2, what would that be equal to? 2 over 2, right? Which is the same thing as a 1. 1s and 0s are going to be our objectives. That's what we're going to try to get. With adding and subtracting, get me a 0. With multiplying or dividing, get me a 1. That, to us, that's what I mean when I say cancel, because they're basically going away. So 2 and 1/2 are opposites. You had a regular 2 and you divided by a 2. So opposite of multiply was divide, right? Here with our fractions right above it, when you had 2/3, think of the reciprocal. Because what would you have here? 2 times 3 on top gives you 6. 3 times 2 on the bottom gives you. So once again, you're getting a 1, right? Okay. So I guess the multiplicative inverses are the harder ones to see. The idea is between these, you could think of it as the opposite of multiply is divide. Or you could think of it as, if I say the word reciprocal, are you guys okay with it? Or should I say, okay. Or you can think of it as use reciprocal. If I could spell it, reciprocal. I can't spell. Oh, okay. I think I've done here. Let's fix that. Maybe I just put it back. Okay. So, for example, this is the reciprocal one up here. And up here on the top, we said with these two that the opposite of plus is minus. And again, when we're thinking opposite, we're saying it either gives us a 1 or it gives us a 0. That means, as far as we're concerned, it no longer exists. It no longer exists, meaning it doesn't change the problem. You know, if you're talking about plussing and minusing, you can plus and minus a 0 all day long, can't you? Okay. That's why if we're talking about addition or subtraction, our goal is to get a 0. Because once you have that, it doesn't change the problem anymore. Same thing down here with multiplying or dividing. You can multiply by a 1, you get whatever you had. You can divide by a 1, you get whatever you had. So when we're talking about opposites with multiply and divide, that 1's what we want because it doesn't change anything. That's why we're saying 1s and 0s are good for each category. So here's the deal. Let's go back to that first example we looked at. X plus 2 equals 4. Oh, wait, I wrote it differently before, didn't I? Let me change it. It was 2 plus x, I think. 2 plus x equals 4. We know that addition, the order doesn't matter, but to be consistent in your notes, I'll write it this way. If you were going to solve using the principles I just taught you, the idea that to make something go away, you do the opposite of what you've got to cancel it. Well, if I wanted to solve for x, if I wanted to get rid of everything on the same side as x, what would I want to get rid of first of all? The 2? Do you have a positive or a negative 2? Okay, what kills my positive 2? Okay, so what's going to kill my positive 2 is a negative 2. I'll write that right below. And to keep this statement true, what I do to one side, I must also do to the other side, okay? Once you have written that first negative 2, guys, you just stamp it on the other side. Don't even think. It has to be the same, whatever it is you do. We don't care what you do. In math, guess what? If you chose to do the wrong thing, we don't care. You better do the wrong thing to the other side, too. If you don't do the same thing, you just broke it. It's not equal anymore. Property of equality is so important, you do the exact thing to both sides of that equal sign. And then you can say, oh, look, I chose the right thing because they killed each other. Bring down my x, since that's left now. And 4 minus 2 gives me that 2. The one that we kind of did in our minds and that we already tested. We knew that was a solution. Well, in this case, the solution. Using this property, if you're reading your textbook, it's called the addition property of equality, saying you can plus and minus on both sides. I actually have already taught you both in the intro, but I'll try to tell you between the two kinds of examples. Let's look at another example. How about example? X minus 4 equals 2. What do we think? You could probably do it in your head. You know what? That's funny. At this point in algebra, I don't want to be mean, but this is the point when a lot of you guys, if you've seen algebra before, probably didn't learn the rules because you could do it all in your head, and that's why you're here. It's because you got to learn the rules on the easy ones, because then all of a sudden you'll blink your eyes and the problems will be completely different. Yes, almost every person in this room already knows the answer, but let's practice the process. This is the building blocks to being able to solve harder problems. The goal here, again, would be to solve for x. If I asked you to solve. To get x isolated, to get x by itself, what am I going to get rid of? 4. Is it a positive or a negative? Okay, so it's attached by a negative. Opposite of negative is? Okay, so I'll write positive 4. Once I've written it on one side, I have to also write it on the other side. Two plus 4 gives me 6. Could you test that to make sure that was indeed a solution? Sure. 6 minus 4. 2. Okay, no mistakes. We know it was a solution. We just checked it in our mind. Okay, good. Let's use a fraction to make sure people don't freak out when they see a fraction. Here's another example. And I just now put x on the right-hand side. Is that acceptable? Sure, who cares? But, I mean, you can always, equals goes both ways, right? You could flip the thing if you wanted. You could say x minus 1/4 equals 5/6. Who cares? It doesn't change the statement. The idea is still the same. Let's get x by itself, right? Okay, what's attached to it that I want to get rid of? 1/4. Okay, the opposite of negative 1/4 is, okay, positive 1/4. What you do to one side, you had better also do to the other side. Well, we know those two cancel because that gave me nothing. And then let's see, I guess I should do some scratch work. At this point in the class, welcome back to having your calculator. You can use those now. Now that you've proven to me that you know how to do basic stuff. If we're doing it by hand, though, I guess 6 and 4, 24 is my common denominator. So it's going to be, oh, 12. 12 is easier, isn't it? We could use 24, but the smallest is the best. So let's use 12. So that was a 6 times 2 gave me 12, right? Then on top, so you have to multiply, remember, same thing on top and bottom. 5 times 2 gives me, okay. Then we have, let's see, 4 times 3 gave me that 12. So 1 times 3 sounds like a 3 on top. What am I getting? 13 over 12? Of course, we know that that's the same as putting x on the left, if we had wanted to, yeah. What do you mean? Oh, so why did I add 1/4 to both sides instead of adding 5/6? Well, it's because if I'm solving for x, my overall objective is to get x by itself. So see how the x was over there with the 1/4? I wanted to kill anything with that x. I wanted x by itself on one side. So to get rid of that, that's why I chose 1/4. Very good question. Yeah. So it was equal to 5/6. And see how when I canceled the 1/4, now on the right I have x alone? That was my overall objective. And then it gave me the 13/12 on the other side. Very good question. So I can write it, I can switch the thing and write it this way. That's the same thing as what, 1 and 1/12? Could you check this to make sure you were right? Sure, plug it in. Up here for that x in the original statement. So what Cal said is a very important statement. X is what you're solving for. That's why when you're killing things, you're being kind of strategic. You're trying to kill things from around the letter you want to know. You're trying to get it by itself. You're trying to isolate it.